Today we're going to look at decimals and fractions. To convert a decimal to a fraction, firstly you need to determine the place value of the smallest part of the decimal, then express the decimal as a fraction of that place value, and then simplify if necessary. So, for 0.25, our smallest place value here is the hundredths. So this is 25 hundredths. So I express it as a fraction exactly that way, 25 hundredths. We can simplify this now. We can create an equivalent fraction that's simpler by dividing the top and the bottom by 25. We're doing the same thing to the numerator as we do to the denominator. 25 divided by 5 is 1. 100 divided by 25 is 4. So 0.25 is equal to 1/4. To convert a fraction to a decimal, firstly we need to find an equivalent fraction with a power of 10 as the denominator. So powers of 10 are 10, 100, 1000, etc. Okay, so they're anything that we can multiply 10 or divide 10 by rather. Then we need to convert to a decimal using the place value of that denominator. So if it's 10 tenths, then it's 1/10, hundreds in the hundreds column, etc. So for example here we've got 3/4. I can multiply the top and the bottom by 25 to get 100 as the denominator. 100 is the power of 10. So 100 means that we're looking at hundreds. So if I go to the hundreds column, I've got 75 hundredths, so that's 0.75. So 3/4 is the same as 0.75. An alternative method that you can use is just divide the numerator by the denominator. Remember the vinculum, that line there that separates the numerator and denominator, just means divide. I mean, even if we look at the divide symbol, it looks like numerator divided by denominator. Okay, so what we can do here, if we're looking at 5/8, is we can do 5 divided by 8. So we put 5 down with a number of decimal points after it, because 5.0000 is still 5, okay, because we're going to try and see the equivalent decimal value for 5/8. So 5 divided by 8. 5 divided by 8. So 8 out here is our divisor and 5 is our dividend. So here we go 5 divided by 0, divided by 8. Can't do that 0, we have our 5 remaining. Okay, so that's 50. 8 goes into 56 times with 2 remaining. 8 goes into 22 times with 4 remaining. And 8 goes into 45 times evenly. So that's 0.625. So 5/8 is equal to 0.625. If we look at some examples now, we need to convert some of these values to fractions or decimals. First one, 10.35, we're converting to a fraction. So this, if we have a look at the smallest place value, here is the hundredths. So this is the same as saying 10 and 35 hundredths. 10 and 35 hundredths. So here, if this is in simplest form, in simplest terms, I can divide the top and the bottom by 5, and I get 10 and 7/20 as our fraction. Looking here at converting 5 and 3/5 to a decimal, I can multiply the top and the bottom by 2 to get 10 as the numerator, as the denominator rather. 10 as the denominator, and that means that here I've got 5 and 6/10. So that's 5 in the ones column and 6 in the tenths column, 5.6. So our 5 and 3/5 is equal to 5.6. If I'm looking at 7/12, I can divide 7 by 12. Here if I put a number of decimal points here after the 7 to find out what the decimal value is, or the decimal notation is for it, 12 goes into 7 0 times, we have our 7 remainder, but 70. 12 goes into 75 times with a 10 remainder, so we've got 100 here. 12 goes into 108 times, and we have a remainder of 4. 12 goes into 40 3 times with a remainder of 4. So then continues, 12 goes into 43 times, remainder of 4, etc, etc. So this is going to keep going. 3, 3, 3, 3, 3, on forever. So this means that our 7/12 is equal to 0.583333 on forever. So this, when we have a number that repeats, and one or many numbers that repeats, it's called a recurring decimal. Recurring, R-E-C-U-R-R-I-N-G, recurring decimal. And we can symbolise that, symbolise that recurring decimal by putting a dot over the value that is repeating. So it's the 3 that repeats here, so I'll put a dot over this over the 3 to show that it keeps going forever and ever. So here, the way we would say this answer is 7/12 is equal to 0.583 recurring.